The next time you buy a canned soft drink, consider this. That aluminum can will always be recyclable. Unlike plastic, aluminum never deteriorates, no matter how often it's melted down and used again. The next time you buy a canned soft drink, consider this. That aluminum can will always be recyclable. Unlike plastic, aluminum never deteriorates, no matter how often it's melted down and used again. Aluminum cans are so lightweight that it's hard to believe they're made from a huge roll of aluminum sheeting that weighs 9 metric tons. The sheet is about 1.5 meters wide and as thin as construction paper. A roll like this is long enough to make 750,000 drink cans. The sheet feeds into a press that punches out round pieces that'll be formed into cans. The punch press actually performs 2 operations. It punches out a disc 14 centimeters in diameter, then bends it into a cup. What's left of the sheet gets compacted and sent back to the aluminum factory where it's recycled into new rolls. The cup goes into a machine called the draw and iron body maker. A tool draws out the aluminum, forming the body of the can. The tool is lubricated so it won't tear the aluminum while stretching it. The lubricant also acts as a coolant because the aluminum heats up as it's being worked. Once the body is formed, a trimmer cleans and straightens the edge. Now the cans move along upside down on the conveyor belt over to the washer. The washer performs a 6-stage cleaning. The first 2 washes are in hydrofluoric acid at 60 degrees Celsius. The last 4 washes are in deionized water, neutral water with no pH, also at 60 degrees. The cans come out of the washer and go under a hot air dryer. They're now shiny because the hydrofluoric acid wash removed a thin surface layer of aluminum. Next, a roller passes over the cans, coating the bottom rims with varnish. This varnish coating allows the cans to slide easily on conveyor belts and in vending machines. It shows up as a blue ring under ultraviolet light. The cans are now ready to be printed. This rotation printing system can apply up to 5 colors, one at a time. The machine then applies a layer of varnish to protect the ink. This is what the print and varnish process looks like in slow motion. And here's the actual speed, 1,800 cans per minute. Next, the cans fly through an oven that instantly hardens the ink and dries the protective varnish. The next machine sprays a water-based varnish on the inside of the cans. This creates a barrier between the drink and the aluminum, so the drink won't end up tasting like metal. It also prevents the aluminum from being eaten away from the inside by the acid in carbonated drinks. Next, the cans go through a machine called the necker, which forms a 5-centimeter neck on the can. This is done gradually in 11 steps so as not to puncture the paper-thin aluminum. The next machine, called the flanger, forms a curved-over edge at the top of the can, which will later attach to the pull tab cover. The cans pass through a sophisticated vision system that photographs the inside of each can. Any can that doesn't meet standards, that has a bump or ink inside, for example, is automatically canned from the production line. They strap the finished cans onto a pallet. From here, they're shipped to the drink company, which fills them, then attaches the pull tab cover. Drinking water that's fresh, clean, and crystal clear is something many of us take for granted. We might not give it a second thought, but between the source and our tap, a lot happens to make that water fit to drink. Our water may come from Mother Nature, but it's far from pristine. It starts its journey to the treatment plant through a water intake pipe. On the wall of that pipe, about 2 meters down, is a 15-centimeter hole. Covering that hole is a metal grill designed to keep out large debris such as tree branches. The water flows to a pumping station where it goes through a preliminary screening. A giant revolving screen removes fish, garbage, and grass. Once they remove the debris, a low-pressure pump moves the water into the treatment plant. The untreated water, called raw water, is dirty and smelly. So they first add a powerful form of the chemical element carbon, called activated carbon. It absorbs contaminants such as solvents and pesticides. That rids the water of bad taste and odor. From there, the water then goes through a series of mixing tanks. The first tank holds a chemical called aluminum sulfate. It acts as a coagulant, a substance that thickens liquid into globs. In the raw water, the aluminum sulfate forms tiny sticky globs called flocks. Bacteria, mud, and other impurities stick to those flocks. Then the flock-filled water moves on to the second mixing tank. The second tank holds a chemical called polymer, which is essential to the next step of the process, called sedimentation. 5 pipes inject the water with superfine particles of sand, called microsand. The polymer coats the sand, making it sticky. The grains of sand then stick to the flocks in the raw water, weighing them down even more. The water then flows into a settling tank where the flocks, because they're heavier, settle to the bottom. You can see the result in this demonstration. The water is finally clear, but it's far from drinkable because it's still full of bacteria, viruses, and other organic matter. So on to the next step, filtration. The water flows onto the top of the filter, then trickles downward, passing through a layer of anthracite, a type of coal, then through a layer of sand. This filters out any remaining particles, which then flow to the middle. But the water is still teeming with bacteria and viruses, so it has to be disinfected. They add 1.9 milligrams of chlorine per liter of water, enough to kill off those germs and bugs. They add a mineral called silicate to prevent calcium buildup from blocking our water pipes. The treatment plant sends water samples to government inspectors who continuously monitor the water supply to ensure it meets safety standards. The amount of chlorine remaining in our drinking water is 0.6 milligrams per liter. The chlorine gas the plant uses is highly toxic. Should any leak out, emergency teams would have to evacuate a 10-kilometer radius. So the plant stores the drums of chlorine in a high-security area. It's taken about 45 minutes to turn raw water into treated water. Now these electric motors will pump it through underground pipes right to your tap.
Like all cheeses, mozzarella starts from milk. To assure good milk quality, the interior and exterior of tank trucks transporting milk must be washed after being emptied. A tank such as this one can carry an average of 30,000 liters of raw milk at a temperature of 3 or 4 degrees centigrade. Raw milk destined for cheese making contains 3.8% fats and 3.3% proteins. They store the milk and whey, a milk byproduct, in these immense silos, each with a capacity of 225,000 liters. This milk separator extracts surplus cream to adjust the percentage of fat according to the type of cheese to be made. Fabrication begins with this tank, which feeds the pasteurizer. Pasteurization sterilizes beverages which can easily ferment. Milk samples are drawn off to precisely determine their milk fat and protein content. Tests are carried out in this laboratory where they impose controls. These test tubes contain milk samples which will undergo microbiological analysis. Milk quality must be impeccable. This is a curdler with a 25,000 liter capacity into which milk and other essential ingredients for making mozzarella are introduced, such as the enzyme rennet that curdles the milk. This mix must be well stirred and cooked. The agitators are used to cut the whey into little lumps. This step takes about 30 minutes. The temperature of the tanks depends on the type of cheese they're making. Agitators continue stirring the milk. Once cooking is done, the whey is pumped onto tables to be drained. It stays there for about 25 minutes. The solid and the liquid are now well separated. The liquid we see draining is called lactoserum. The lactoserum will be concentrated and transformed into milk byproducts. The water has been almost entirely extracted and the cheese particles are now sufficiently dry. This large automated blade then moves cheese particles towards the next step. That is toward the molder. In the molder, the cheese is cut up before being carried to the cooker, the final processing step. It appears that this mozzarella has just the right texture. The cheese finally arrives at the molder, which will give it the proper shape. Each mold has a 2.5 kilo capacity and is rectangular. Brine, a salt solution, serves to cool as well as to salt the cheese blocks. The blocks are unmolded and fall into a brine tank. Following on, the cheese blocks will remain in another brine solution for a while. They are then carried by a conveyor towards another tank, where they will be immersed for 4 to 10 hours at a temperature of 2 degrees centigrade. Sprays of brine remove the foam which forms at the surface of the tank. The 30,000 liters of milk that we saw coming in by truck at the beginning have enabled them to produce some 1,400 blocks of cheese in only 8 to 12 hours. The cheese blocks are finally vacuum-packed, ready for shipment.
Scan the snack food aisle of your local supermarket, and you'll notice that barbecue, ketchup, and salt and vinegar flavors are no longer limited to potato chips. Nuts come in tantalizing taste choices too, but if you're a traditionalist, you can still buy them plain, salted or unsalted. The botanical definition of a nut is a dry one-seed fruit in a hard shell that doesn't open on its own. Most peanuts have 2 seeds, so even though we call them nuts, they're technically a legume, a type of pea actually. One way to prepare peanuts for sale is to roast them whole right in their shells. This is known as dry roasting because they cook the peanuts without using any oil in a large convection oven. The oven temperature is 149 degrees Celsius. The roasting process takes about a half hour. When the peanuts come out, they're fully cooked and ready to be cracked open and eaten. Before the peanuts go off to be packaged, a worker inspects them, removing any shell fragments and foreign matter. Another way to prepare peanuts or other nuts for sale is to dry roast only the seeds. These peanut seeds arrive at the factory with their shells and skins already removed. A conveyor transports them to a revolving drum called the tumbler. As the tumbler spins, the nuts are sprayed with a liquid seasoning mixture, one of 10 flavors this company produces, such as salted, smoked, ketchup, barbecue, and salt and vinegar. The rotating action ensures the seasoning coats the nuts thoroughly. Now a conveyor transports the peanuts to a convection oven. The conveyor turns from side to side, spreading the peanuts in a thin layer so that they'll dry roast evenly. They roast for the same length of time and at the same temperature as peanuts in the shell, about a half hour at 149 degrees Celsius. As they exit the oven, a worker breaks up any clumps. They tumble on the seasoning after cooking when they use the other method of preparing shelled nuts. Instead of dry roasting the nuts as we saw earlier, they fry them in oil. This process is called oil roasting. It gives the nuts a greasier fried taste. These cashews are on their way to be oil roasted. They go into a huge frying tank containing 2,200 liters of canola oil, heated to 160 degrees Celsius. When the nuts come out fully cooked 15 minutes later, they're steaming hot. A powerful ventilation system draws the heat outdoors, cooling the cashews to room temperature. This takes about 15 minutes. By now, the nuts have absorbed any cooking oil that remained on their surface, so they receive a light spray of vegetable oil. This makes their surface sticky again, so that salt or seasoning mix will adhere. This factory also produces nut mixes. Here, the mixer is combining various nuts with dried fruit. From there, it's onto a packaging machine whose 8 computer-programmed scales automatically weigh out a specific package portion. But before each portion goes into a bag, it passes through a metal detector. This ensures that no shards of metal have worn off the equipment and fallen into the food. The machinery hermetically seals the plastic packages. This keeps the contents fresh for at least 6 months.